So I'm going to talk about a plethora of things today, and one of the thing which I'm going to start with is probably one of the most fundamental of human emotions, and that is fear, right? We all get afraid, come on. So, the commonest fear and the most ancient is the fear of unknown. Like since antiquity, humans have been afraid of the unknown, and there have been a lot of people who have actually acted upon this fear, who actually have feared it, and that's why Greek mythology and the ancients, they made gods. They had so many, they had gods for everything. They had gods for whatever they feared. They had even gods for fear. Phobos is the god of fear. So the Greeks had that. But few of the Greeks and the few of the ancients, they were like quite a bit different. They actually revolted. They actually wanted to create God. There were people in history, though they were banished and they were like not received properly, they had this idea of creating God. And artificial intelligence, what you see now, the buzzword artificial intelligence, actually comes from this ancient desire to forge God. And probably the best example of that is in the Antikythera mechanism. It was found in 1902 and it dates back to 150 BC. It was by the engineers of Julius Caesar, and actually this is an intricate mechanism of over 30 gears, thousands and thousands of small parts. It was engineered before Christ, and it could predict the motion of 5 planets, the moon, the sun, with all its irregularity in an astounding manner, which even the 17th and 19th century astronomers could not. And it was made in 150 BC. So there were challenges. There they actually wanted to understand how the world works. There were people who actually dedicated themselves into this. This is how it works, and this is this extremely complicated thing. This they made in 150 BC. Another of such a person was Heron of Alexandria. He was revolted. He was a iconoclast, and he also invented the famous formula you know him of. But with that, he invented these amazing things, this wind organ and these machines. For the first time in human history, people created, like he was one of the first people who pioneered creation of something artificial. Like before him, everything was natural. Like we used natural, we farmed, we did things. But he actually took up those natural elements, made them together, stuck them together, and made something useful out of it. So he was one of the first people, and there were a lot of them to follow. Actually, when the ages progressed, there were the dark ages, and after that there was this desire to forge the gods, which remained. So people made these mechanisms, and people invented things and started doing things, but this actual desire to forge God remained. And actually the basic question which was also behind this desire of forging God was actually, what is consciousness, first of all? Like, what are we made of before God? What are we made of? Like, what does this this table has, what does this table does not have, and I have, what you guys have, and what does this chair or this camera does not have? What was this consciousness? And people thought for a lot of time, and probably one of the best answers was given by Rene Descartes. What did he do? One day he sat down to think that, suppose, what if I don't have my body with me? Would I still be there? And he thought, yes. I mean, what's wrong? It's my body, but this my is still there, right? The next moment he thought, what if I don't have my mind? Would I be there? Though I have my body, without my mind, I am nothing. So he came up with this extremely famous saying, I think, therefore I am. And this was actually one step forward to the direction of thought that if we want to forge gods, we need to understand us, and what we were made up of is thought. The mind is what we were made up of. And one of his contemporary Leibniz, he was one of the people who invented the integration, for the people who can connect to. He lived the same dates, and he envisioned a universal language of reasoning. So what he thought, that as Descartes said, whatever we are and whatever we do is all about thought, he said that there should be a universal language of thought, in which you could, if there is an argument, you could convert it into calculation, right? So everyone would agree upon that calculation, because there are diverse arguments, but they should converge to actually one simple calculation. That's what he believed. And so This actually, so this artificial intelligence back then was built upon the assumptions of the philosopher that thinking can be mechanized, right? That thinking, everything in thought can be reasoned out, everything can be written down, can be calculated, can be mechanically, done. And this actually took actual shape, not in the 1700s, 1800s, but in the 1940s, when this is Moore School of Electrical Engineering, University of Pennsylvania. They made one of the first computers. And when they made the first computers, they had something in front of them that could add, that could multiply, right? And addition and multiplication, what we think is something we need to use our brains for, right? Now man had created something out of what nature had given him, artificial things what nature had given him. Man actually took up, joined things, stuck things together, and now created a mechanism which it could, replicate this thought process of adding and multiplying. That was surely some progress in forging the gods. And so people started. So in the 1940s and 50s, a handful of scientists from a variety of fields got this new thing called a computer in their hands, and they decided that let's model it and make it, something useful. Let's model the brain out of it. Now it can add, it can subtract. There'll be this formal language of logic, and we'll write it down and we'll convert it into additions and subtractions, and let's actually make an artificial brain. And they were seriously considering the possibility, and so they were good at that. They were brilliant people, but there was this one fellow who actually started taking this thing actually very seriously, but he noted that thinking is very difficult to devise. It's very difficult to define even that whether something has thought or not. So if I could make something which could do things, but how would I be sure that it actually has thought before it has done that? So he devised something called the Turing test or the imitation test, in which he said that, say, I assume a room in which there is a person outside of it, and we put a machine inside of it, and the person can ask any random question. Now the machine should be able to answer that person in such a way that the person outside should not be able to differentiate whether there is a human inside or there is a machine inside. If that is so, then that machine has actually thought, because the question that fellow is asking is random, and that cannot be hard-coded. So this was actually a small step in actually quantifying of what we can say, what intelligence we assume, what we can say is intelligent and what is not. So that was Turing. And in the 50s, there was this thing called computers where, very university things, they were huge things, and only universities had that. Now there was an era of, and there are a lot of people who were interested in commercializing these computers and selling it to people. So one of the best things they did was created games. There were a lot of computer games in the 50s. It was very, very, very primitive games, like worse than any things you have seen in your life, but there were, right? And so what people did was, they saw that they made such games, and there was this other thing, that video games like chess, like checkers, in which we actually need to use our brain. Why not actually automate them? So one of the first attempts to automate, game was done by Arthur Samuel. He made a checkers program in 1956, and that was probably the first time ever human was playing in front of a computer. Like a non-living thing is playing a game, is moving a piece, it's conceptually, changing state of a game without any other human intervention. It's like a game made for a human, to a human. It's now done by a machine. It was the first time. And in 1956, actually, when these things were happening and computers were being developed, a lot of people got serious into this thing, and all of them sat down together at this Dartmouth conference in 56. It happened in Dartmouth College in New Hampshire, and all of them had some notion of AI, that they wanted to pursue certain areas of it. Everyone got together and thought what this AI is. Everyone thought that if they are serious, they got other people who are serious in it too. So with that, and actually a revolution was boomed. There was an AI booms. Now all of these great minds who gathered together were professors from brilliant universities. They came from diverse backgrounds, from diverse nations, and all of a sudden in their labs they got this new seriousness about this artificial intelligence. And we made computers solving algebra word problems and learning to speak English, and everything started. And researchers back then, actually they expressed a lot of optimism. They said that we are gonna make an artificial brain in next 20 years, and this is gonna be the new great thing in science. And so the government agency like the DARPA, the US Defense Agency, they poured in money like anything to this thing. In 1958, MIT, which is probably one of the world's leading institutions, they had the Artificial Intelligence Laboratory, like before even computers touched India, and it was founded. And Few years later, they got $2.2 million funding, and similar grants were given to Stanford, CMU, and Edinburgh University for AI research. So like the government was supporting, there was a huge boom of researchers, everyone was interested, and then came robotic arms. They were making robotic arms, and they were making parts for things, and they were making these chess playing AIs came out after the checkers things, and people were doing an n number of things with this artificial intelligence, and it was all going good. But there were some difficulties. Say you have this problem of solving a maze through AI. What we had to do is actually hard code it. If you don't go here, then go there. If you don't go here, then go there. And for that, if you see, if there are like 10 walls, there are 1,000 possibilities. But if there are 20 walls, you would see there are 2 million possibilities. Imagine a 20-walled maze. If computers want to solve, it will take 2 million possible moves to solve. And what if for 21? It's multi 4 million, and it grows exponentially. So there is this problem that if you want to solve a small problem, even like a maze, there are so many ways in which that could be solved. So what if this maze? What if this maze? And this could take ages and ages, more time than the age of the universe to solve. Better I do it with a pencil and paper. So there were some revival attempts. A lot of revival attempts that they made some smart moves, they eliminated some paths in the maze here and there, but actually a lot of the smart minds finally failed due to severe hardware constraints, and they were like so primitive computers back then. Like this was 65. In 1969 when Neil Armstrong went to the moon, he had 4 MB RAM in his computer. 4 MB, like a million times slower than what you have in your phone. So whenever you feel demotivated, whenever you think your phone is slow, imagine man went on the moon with a software million times slower than yours. So it's like, and there was this huge hardware constraints in the AI industry, and if you wanted to do normal things, you wanted AI to think, we need to pull in so many information, right? So that information, there was no way of getting the information in. So there is this AI winter. And back before Game of Thrones, this title was given. So there was this AI winter, 1968 to 1980, everything stopped. Like funding stopped. There was no progress in AI. There was this difficulty that there were too much hardware requirement, and there was no research in AI. So this was a huge problem. So in the 1980s, there was a concept called expert systems. It came into the picture. There were people who were selling these expert systems. Now what these things did was, there was a user interface and there was a knowledge base. Now some non-expert person would ask a query, and some expert would have made this knowledge base. So a query is asked, there is a processing in which it selects what answer to give, and it gives the answer to the user. So this was extremely good. They made chat bots from it, they made FAQ bots from it, we were like doing simple things with it. And Mycin was an expert system. It was developed by Stanford to identify bacteria causing severe infections, and to recommend antibiotics. So you say that you have this problem, you say the symptoms, and this knowledge base will tell what antibiotic to use. So it was the most basic AI in medicine. So a lot of practitioners did not trust this, but it was something to start with. But now there was another problem, and the problem is the knowledge base problem. Someone has to put that knowledge base. Someone has to write all of those things in that knowledge base, right? And like if you want to do something like general intelligence, like something that talks normally, we need to put millions and millions of data points. We need to put so much information into it, like everything about the world. And people actually tried to do so. People proposed projects and got $1 million grants for that. But actually, it did not turn out to be well. And there was this second AI winter. And things didn't work out well until 1993. This thing came up, self-training models. So what these things actually, now the computers had grown up. So now we had computers which could store things, which could do things very fast. So what these things did was, say if I have a chess game, I program my chess game to, say if I play, it was programmed in such a way that if I play with my chess game, and if the chess game makes a mistake and I win the game, the strategy of the chess game is penalized, and there is a new strategy to be taken which is better than the previous one. And that way, if I play it with multiple times and if we defeat it all the times, it will finally become smarter than me, because every time it selects a better strategy than me. One day it will be smarter than me. And so people are playing chess. A very smart person realized that what if we could play that chess with itself? So we had an AI which played chess with itself. So every time it lost, it became better, and that it became better than that, and better than that, and better than that. And there was DeepMind, something by Google, and it defeated before Google. It defeated the world chess champion. This simple logic defeated the world chess champion Garry Kasparov, and that was the epitome of the success of the AI game. So that the smartest game, probably one of the smartest game, and the smartest people in the world are defeated by AI with a simple concept. So that was one thing, but that was only games, right? We don't play games all the time. We need to solve real world problems. So for that, there was this 1993, there was a University of Toronto professor, Geoffrey Hinton. He gave this amazing model which changed the world. He said, let's have a model which learns. What we do is, we ask questions to that, we give questions to that model, and we also give answers. And let model generate random questions, like random answers. Any answers. Now based upon now we know the correct answers, right? Now based upon the random answers, like the correct answers, we'll penalize the model, we'll train the model in such a way that every time we'll force to answer correct way. So we train in the questions, we'll give something random, but every time we give a new question and we force it an answer, finally after thousands and thousands of questions and thousands of answers, it will actually learn of what answer it should give. So now when you have like say thousands of questions, it has in the model, and the thousands of answers along with that, now the model has actually reasoned out that this question means this answer, this question means these answers. So when you have new questions, it will give you new answers. Getting it? So that was the idea. It was, if you give it an example that this is the question, this is the answer, and this is the solution. So then this actually led to an AI boom. Brilliant things happened. It had lots and lots of application. One of the first of them was face detection. What people did was, people gave what images and they said, this is the face, this is the face, this is the face. Thousands of millions and billions of images were given, and finally the AI was so smart, then you give a new photo, it will tell whether there is a face or not, because it has seen millions and millions of them. Object identification, we could identify any object from any image. Where the AI had known thousands and thousands of images with the object. Now when you see a new object, it will recognize that yes, this is the right answer. And with that, there were chatbots, image interpreters, actually interpret images with handwriting and voice recognition. You see thousands and thousands of voices were put inside it, and text was given that this is the right answer to the text. And now when we say a new voice, it will actually generate the text for us. Stock analysis, there was weather prediction, a lot of weather reports were put in with the correct answers. Now when you put the analysis, it will actually give you the temperature and the forecast. Sentiment analysis, actually when you say a sentence, it's a positive sentence or a negative sentence. So trillions and trillions of sentences were trained with this is positive and this is wrong. So when you now narrate a speech or say a sentence, it will tell you whether it's a positive or a negative. People have predicted election polls and views of politicians using these things. And they're brilliant things. But what I actually want to tell you is about medicine. That companies like Microsoft and IBM are working on things like chronic disease treatments, determination of the best cancer treatments. So what they do is, they take in millions and millions of reports, the diagnoses of the doctors. They say they take in the symptoms as questions and the diagnoses as answers. And after learning millions and millions of those questions, finally when you have a new new symptoms put inside it, it will give you the right diagnosis. So that's the idea. And tumor progression, there's image analysis, the cardiac risk prediction, you tell the history of the patient, there is a lot of history already given to the computer. Now when you say new history of a patient, it will predict what age there is a cardiac risk, and so many more of that. So there is this thing called, will AI replace doctors? Like we have these machines and finally they'll be making reports and you go to them and just tell your symptoms and they scan you as you show in science fiction movies. Actually that is false. That is not going to happen. We need the doctors to ask questions. We need to ask doctors to give the answers, and based upon that we will design our models, and based upon that newer questions would be asked and newer answers would be received. So we doctors, we actually need you. You tell us that this cardiac risk determination is a problem. You tell us that the cancer drug treatment is a problem. You give us your problems, you give us your diagnosis, and then we'll make a system which can assist you in working. We won't replace you, because we need you to ask the question, we need you to answer the questions so that people can ask the new questions. Right? So doctors, we really need you. And in this era of actually interdisciplinary research, this learning by example AIs are going forward. So when the doctors will say that this is this problem we are facing, the engineers are going to design models for that which can learn. But the problem and what the solution, the doctors will have to give. Like when doctors said we wanted to see inside the body, physicists designed the CT scans machines and X-rays machine. Every time in history, when doctors have problems, the physicists and the computer scientists will actually, design things for them. So AI is not going to hurt you, AI is not going to replace you. In fact, we want your help to come with us, work with us, collaborate, and help make us make AI which can be beneficial for you to the future, right? So we have, like, all the machines, like, finally I would just say that all the machines we have seen and all the things we have, like, we felt and learned in college and wherever, we are always taught that this is known as this and this machine looks like this, because someone else, people who were before us, thought of how we make them, right? But now is the time we'll invent our own machines. Now is the time, the next generation of AI, that we as computer scientists, engineers, doctors, all of us get together and solve problems of the generations for the generations to come, and make our own machines, give them our own name. And so the future is you. Welcome to the future. Thank you.